All right, we got this potato problem. I don't even know what it says, a boiled potato. I don't even know what that is, man. You gotta get some like flavored mashed potatoes up here, like some garlic mashed potatoes, man. I don't even know, man, but there's some good flavors out there, but I'm not even sure. But we're gonna take this potato out of a pot on a stove, and it's gonna cool off. All right. And then they're using H as the temperature of that potato, just because, like, I don't know why they're using H, because T is the time, so H is just like hot potato, right? And so this is how fast the temperature of this potato is changing. Now, I just want to tell you before we get started this one, this is like a different kind of problem. There's a couple things that we're going to do here. You're like, oh yeah, that makes sense, but we didn't really do some of that stuff before possibly, but I'm just going to share with you the way this stuff is worded. My students walked out of the test that year. They're like, man, Mr. McGee, like that problem was exactly like the one that we practiced like yesterday, because I remember like the day before the test, I typically will like rummage through my stuff. And if I find anything that looks a little bit different than what we've done, I kind of give them some experience with that. And so this won't be the only problem that you see like this. I think it was like the 2011 test. There was one that was practically identical to this one. It just wasn't involving a potato. It was just like talking about a landfill, but you'll see that one in the future. So we'll have a couple of them to kind of go off of, but just like the weird notation stuff with the second derivative that I think is good to kind of see. All right, so now let's finally get into this thing, right? When you see equation of the line tangent, that means you're about to find the equation of the tangent line. So it says that t equals 0, but then when t is equal to 0, that y value is 91. So h of 0 is 91. So our point is 0, 91. And then to find the slope, we got to plug into the derivative. Now, normally, you're used to plugging in like t equals 0 into your derivative, but when you go to your derivative, there's no t's in there. So that's a little odd, but we know when t equals 0, that h is equal to 91. And since my derivative has h's in it, I have to use the 91 for the h. So at t equals 0, h is 91. So I plug in 91 minus 27. And then that was going to be 64. And I kind of did 64 in my head, but then I just want to be extra cautious. So I went did like old school, subtraction over to the side right there. And then the 4 to 64 together is going to give us the negative 16. So there's a slope of the tangent line. And then we already said the point, do your point slope form. And I know that the x's are the t's and then the y's are the h, the temperatures. So there's the equation of the tangent line. So they want us to write that equation first and then use that equation to approximate the internal temperature at t equals 3. Now I have a t in my equation, so I can plug the 3 in right there, times by the negative 16, get negative 48 plus 91. Again, I did that in my head, but then I just did like old school arithmetic over to the side just to double check myself. Now, letter B, couple parts of this. One part's going to be easy right away. Second part of it is it will be easy for us, but it's not something we've done all the time. So when you see this notation, that means we're going to do the second derivative, which means you're about to do the derivative of that guy right there. So that's a constant, so that's going to carry down. And when you do the derivative of h, you get 1, but you just did the derivative of h is with respect to time, so you got to tag on a dh dt. And then so the negative 1/4 is there, and then it tells us usually you're going to use this for something. So this DHT isn't going to help us out. A lot of times it'll tell us in terms of T or H, so we have to get rid of that DHT, but usually you end up plugging in that DHT with what it's equal to. So you just take that and insert that right there, and then we're going to get that 1/16 times that H minus 27, right? So here's our second derivative. So they want us to kind of find that, and then it says use it to determine whether this answer in part A is an under and over estimate. Now, anytime we use the second derivative for something, we use it to tell us whether that particular thing is concave up or concave down, which means we always want to figure out is the second derivative positive or negative. And then it tells us at t equals 3. So when t is equal to 3, again, there's no t's in there, there's just an h in there. But in letter A, you found out when t is equal to 3, that h was equal to the 43. And then so 43 minus 27, you don't even have to do that with arithmetic. We know that's going to be a positive number. Now, since the second derivative is positive, we know that graph is going to be concave up. And then so because that second derivative is positive, and because that original curve is concave up, the answer in part A is going to be an underestimate. So what I did to the side, I said, okay, if I have a graph that's concave up, you're using the tangent line to approximate something. So your tangent line is going to be below the curve. And so the point on the tangent line is going to be down here, but your point on the curve is going to be up here. So anytime you use the equation for a tangent line to approximate something, and if it says is that tangent line approximation an under or overestimate, you use that second derivative. Because if you have a graph that's concave up at a point, And then think about at that point, let's say your tangent line is there, or you have a point here, your tangent line is here. It doesn't matter, like all the tangent lines. So if we just look at this tangent line and you use it to approximate some y value. So if I plug in x equals 3 and I get a y value of that, then that's where it's at on your tangent line. That's like the answer you're getting from part A, but see your actual point on your curve is above that. So since your tangent line is below, that's an underestimate. And if your graph is concave down, then all your tangent lines would be above. So your tangent line approximations would be over estimates because your actual value is down here, but your tangent line approximation is up there, like on your XY axis right there. So kind of good to see. That's something that if we haven't done a lot of it, we got to make sure we study those, practice that without the calculator, be careful with the notation and stuff there. And then letter C gives us a giant paragraph. I'm like, why do I got to make this complicated? But here's the key phrase here. Like, you see derivative, and then they want you to find G. So you got to just come up with that G function. So once you're supposed to find it, that means you got to go from the derivative to the original function. Here's where you're going to integrate both sides. Remember your plus C. Use the point that they give us to figure out what that C value is, and then we can use it to plug in that T equals 3 right there. So I'll start with that. We've done a bunch of these. It's a differential equation problem here. So the thing is, I'm going to multiply by the dt, and any G's have to be over there with the dg. Any T's or any extra stuff there, probably just leave it with the dt. So I'm going to divide both sides by that. So instead of doing 1 over that, I just made it to the negative exponent, dg, and then I just left the negative over there. Doesn't matter if you move the negative over there, but you're going to move it right back because you just got to solve this for G anyways. But if you got any T's, because it's got to be with the dt. So once you separate your variables, then you're going to integrate both sides. The integral of -1 is negative t. Stick the plus c right there because the derivative t is 1, right? And then a negative carries down. Remember, this is like a u to the -2/3. When you integrate u to the -2/3, you're going to go u to the 1/3. You're going to divide it by 1/3, which means you're going to times it by 3. That's where I got that 3 right there. And then you got that g minus 27 to the 1/3. All right, and then once I integrate both sides, I like to stop right here, plug in that point that they give us, plug in the 91 for the g, plug in the 0 for the t, and I did the old school arithmetic over here just to be careful on there to get that. That's actually, I don't know why I just did the same. It was the same exact problem over there, so I don't have to do it again. But like I said, I just kind of did it in my head and just double check myself there. But you're gonna get the cube root of 64, which is 4. 4 times 3, you're gonna get c is equal to 12. Pop that back in right there, and then usually we could solve this for the g function. Particularly, you wouldn't need, actually, yeah, it does say find an expression for g of t, so you need to solve this for the g of t. Plug that back in right there, divide everything by 3, cube both sides, move the 27 over, and then that's your expression for g of t. And then it says to use it to find the temperature of that potato at t equals 3. So plug in 3 right there. 33 is 1, negative carries down, -1 plus 4 is 3, 3 cubed is 27, 27 plus 7 is 54 degrees Celsius right there. Dogs and basketball. I remember growing up playing basketball, we had a couple golden retrievers. I would grab that basketball to go outside, and that one golden retriever just right away just went right with me to that door. She would just like lay out there with me while I was playing some basketball, man. Dogs and basketball, some good stuff.